Hello, my name is Matt Bernhard. I'm a PhD student at the University of Michigan, and I'm going to talk to you today about some work we've done looking at security and privacy of redirects. And these slides are a little old, unfortunately. Browsers, there's a lot of good security work that's been done on browsers. Mozilla has rolled out a lot of really great technologies, and things like, as we heard earlier today, tracking third parties are fairly well understood parts of, the way that we secure end users. However, redirects have not been as independently studied, or have not really been studied on their own. They've been studied in context of third parties and so forth. And so what we wanted to do was look, if we just set redirects kind of on their own, what are the security and privacy aspects of them? So just a quick, brief reminder, redirects are a fairly critical part of internet infrastructure, especially as social media platforms and so forth have become bigger. We see redirects used to fix the format of links, to shorten links. We also see them to blind, web content behavior, to enable tracking and so on and so forth. So there's sort of a wide variety of functionality that redirects support. And unfortunately, this can lead to compromise of security and privacy, right? Things like drive-by downloads, cookie leakage tracking, so on and so forth, are all enabled by redirects. So one of the first things we did was we tried to sort of taxonomize redirects. In the process of a redirect, what can happen? There's sort of, from a TLS perspective, there's sort of two things that can happen, right? You can either be using TLS or you cannot be. So this is just sort of a brief diagram of all the different ways that TLS can be turned on and off via redirects. So one thing we were trying to set up a measurement platform. How can we measure the impact of redirects? And what we decided to do was use Twitter links. So we collected 7.4 million links from Twitter from verified accounts that had over 1 million followers. So it'd be like that link there. And then we pulled out 100 million of those at first and crawled them using OpenWPM. But that was really slow. OpenWPM is not really designed for this specific task. So we built a new system called Tilt that it adds some sort of asynchronicity and stuff that makes crawling redirects a lot faster. And with that, we were able to process over 10 redirects per second, and we could actually crawl our whole data set using Tilt. Some sort of brief results. This is still an ongoing work. We're still kind of fiddling with exactly how the measurements are done and what data we're collecting. But from our preliminary results, 23% of redirects take less than 100 milliseconds, which is well below the threshold for users being able to recognize that even a redirect has occurred. 70% take less than a second. And in terms of redirect chains, so you get redirected from site A to site B to site C, something like 50% of those happen in under a second. So redirects, if things like TLS downgrades are happening or cookie leaking or something like that is happening, it's going to be fairly imperceptible to users. We saw 1% of redirect links resulted in downgrades to HTTPS, which I think is actually pretty good. 10% never go over HTTPS, so there's never any upgrading that happens, which I think is roughly in line with TLS deployment across the web. And one of the more interesting things that we found is that 4%, it's actually closer to 5%, traverse international borders. So, if you're visiting a website and you, for some reason, your traffic now suddenly goes over an international border, you might be subject to different data privacy laws. So, for instance, GDPR or something like that might come into play suddenly. And this also has implications. California has a privacy law that is about to go into effect that might have implications there. We have some sort of very tentative evidence that there are some risks that redirects pose to users. We heard about some of the tracking defenses earlier today. So what we propose to do is build a browser extension to shortcut redirects. And so the way this works is that we have a browser extension, and then we have on the cloud, we have our Tilt system running. And so when you click a link, the browser extension will send that link to a sandbox in the cloud, which will execute all of the the redirect paths, and then whatever the final URL is that it gets, it'll send it back to your browser. And the hope there is that we can set this to be super strict, where it'll just strip out all possible tracking cookies and so forth, or it can be a little bit more permissive. What we don't know yet is whether or not this totally breaks the internet. That's something that we are working on right now. Redirects are a critical part of internet infrastructure, so we can't just get rid of them, kind of like we saw with tracking and so forth. A lot of work is still ongoing to try and better understand what's going on with redirects. So with that, I want to thank my collaborators, Drew Springall, Steve Sprecher, Alex Holland, and Roya Insafi. And thanks to Steve for inviting me to talk and also helping us learn how OpenWPM works. So thanks.
Okay. Thank you very much.